studied. Any section, do you need any help with any section? Anything? Anyone? Okay, this is the very last topic, I promise. It's the last section. And it deals with a lot of things. It deals with sequences. Sequences. I'm not going to define sequences just now. Factorial notation. And summation notation. Okay, I'm going to start with something easy, factorial notation. This is a notation that is, for example, 5 factorial. 5 factorial. This is 5, that's the largest number, times the next one in line, subtracting 1, times the next one in line, subtracting 1, times the next one in line, subtracting 1, and that's it. Till you get to 1. That's it. You cannot.
Exclamation point?
Yes.
Oh.
The exclamation mark. Yes. So you cannot go beyond 1. 1 is the very last. So then when I multiply these two, I get 20. When I multiply these two, I get 6. 20 times 6 is 120. 5 factorial is 120. Let's take our calculators and see where this is in the calculator. So go to math. Kayla, did that work, that product?
Yes.
Okay.
I was just being.
Just don't forget, always when you have a fraction, whatever you have here have to be in parentheses in the calculator.
Too many math rules in my head. I was
That's okay.
forgetting.
That's okay.
I'm sorry.
Now, no. But if this is just a number or one factor, you don't need parentheses. But if it's 2 times 3, you need parentheses. Okay?
Thank you.
Thank you. Perfect. Okay, so we want to go.
I'm so frustrated.
But that's why I don't know how many of your professors give you their cell phone number, but that's why I give you my cell phone number, so you don't get frustrated, so you don't spend 5 hours.
Yeah, it really helped. Thank you.
Yeah, I mean, that's why I don't have anything to hide. Okay, so let's go to math. All the way to probabilities. Scroll to the right to probabilities. And you see this symbol number 4? We all see number 4.
Yes.
Okay, so first we have to put 5 in. So let's clear all of that. First we put 5, then we go to math, then we go to probabilities, then we scroll down or just enter 4 till you have 5 factorial. Once you see 5 factorial, just press enter. You have to get 120 because we already calculated it by hand. Everyone with me?
Yes.
Is this okay?
Yes. That seems pretty easy.
Yes. Okay, very good. So in general, let me give you the general formula because that's just an example. Before we look at an example, I want to just show you that 1 factorial is just 1. And I know you wouldn't expect this. 0 factorial is also 1 by convention. We've never seen this before. 1 factorial to be 1 and 0 factorial to be 1, but this is the case. In general, for any number, we will write the definition like this. N factorial. And remember what we wrote. The same number multiplied by the same number minus 1, then multiplied by this number minus 1, then multiply by this number minus 1, dot, 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 exactly 3 dots, 3 times 2 times 1. So that's the general formula for a factorial.
So I just want to make sure I understand this. So it would be 7, I mean not 7. If we were using the 5 factorial again, we did 5 times 4 times 3 times 2 times 1, right?
Yeah, so this is 5, this is 4, this is 3, this is 2, and the next one is 1, and I have to stop.
Okay, thank you.
Another way, for example, if I have 17 factorial, I could write 17 times 16 times 15 factorial if I want to stop. I don't want to put everything. For some reason, I need 17 factorial, but not from 17 all the way down to 1. It's a product. Remember, it's a multiplication only. No addition, nothing, just multiplication. I can say 17 times the next one, 16, times the next one, but I want it to be factorial because that will mean 15 till 1. So I may have a use for this. And I just would like to simplify a couple of examples from the book on factorials. On page 752, okay, so let's say 26. And 26 we have 20 factorial divided by 2 factorial times 18 factorial. You cannot multiply factorials. You cannot multiply and say that this is 36 factorial. No, no, no. Every number is something completely different. Which of all these 3 factors is the largest?
Is that 20 factorial?
Very good. 20 factorial is the largest. Which one is the next in line?
18.
Yes. So here's what I would like to do. Since I have 20 at the top and 18 in the denominator, let me know if you would like me, if you accept what I'm going to write. That's why I gave you that example over there. Do you accept the top? Is the top okay?
I don't understand why. Oh, okay, because you're trying to go 20 to 1, so 20. Okay, I get it now.
Is that okay? Everyone?
Yes.
Good. So what do you think I'm going to do next?
Cancel out.
Right. Exactly. So the numerator is only 20 times 19. And the denominator 2 factorial is 2 times 1. So I can replace 2 factorial by 2. And then, of course, I'll simplify. And I get 190. And you can say, why don't you put this in the graphing calculator? Oh, I don't know if the calculator can handle this. Let's give it a shot. It may. But if you try 20 factorial with a calculator, it may give an error because it's such a big number. I don't know. Maybe it will calculate. Okay, it did. 2.43 times 10 to the 18th power. But if I put 234, and if I want factorial, I don't think it can handle that. We'll see. It says error. It exceeds the capacity of the calculator. Calculation exceeds the memory. You cannot do that much. So be careful with factorials. If you can simplify, you should always simplify. Now, if I put it as a fraction, it may work. I don't know. But it worked with 20 factorial, so probably it will work. So careful with that. Do we need another example of simplifying factorials? Let's do one more. Let's say 27. In 27, there are no numbers. N plus 2 factorial divided by n factorial. And now please tell me which one is bigger. The question is the same. We are asked to simplify this. Which one is bigger?
Would it be n plus 2?
Of course. Good. So then I'll leave n factorial alone. And how do I write n plus 2? What is the first number I have to write?
2.
I have, whatever this is my starting point. There is no two ways about it. Whatever this is my starting point, right?
So it'll be n.
So what is the first number?
Two? No.
What is the first number?
0.
This is the first number. What is the first number?
N plus 2?
Thank you. Subtract 1 and give me the next number.
n plus 1.
Excellent. Subtract 1 and give me the next number.
M.
Very good. And I will definitely stop. Why am I stopping at n and not continuing?
It's in the denominator?
Because I will simplify with the denominator. Very good. So the answer is n plus 2 times n plus 1. And of course, this cannot be done with a calculator. I will distribute, combine like terms, n squared plus 3n plus 2. Okay, so from our list, for now we accomplished factorial notation. Let's move on to the summation notation and see what that means. And we can go back to other examples. Sigma or summation notation. So let's suppose I want to add 1 squared to 2 squared to 3 squared to 3 dots, 10 squared. Is there a way of condensing this? It's a sum of numbers. Is there a way of condensing it? Can I write it in a very condensed way so that I don't have to write this, and when I look at the condensed way, I know what it means? And the answer is yes. This is the Greek letter, this is the Roman letter or Latin letter S from sum. But the sigma is a Greek letter, and it looks like this. It's the same thing. It's still S, but this is the Greek S. This is our S, but this is the Greek S. Why don't we use this? You will see in a moment, because this is not the best shape that we need here. This is the best shape. Okay, so what does this mean? It means that I'm adding how many numbers? From the first number, let's say from I equals 1, this will be for I equals 2, this will be for I equals 3, and this will be for I equals, what do you think?
10.
Very good. So this is called index. The lower limit is 1, the upper limit is 10. So then from I equals 1 through 10, from what? From I squared. It looks complicated. Let me give you another example. And let's also calculate this, because we can. So 1, first of all, is the lower limit. The lower limit for the index, the lower limit. It doesn't go below. That's the lowest. I equals 1. And this is the upper limit. So from 1 through 10. How do I calculate this? Let's see what it is. Get your calculators. Let's go to math again. But this time scroll up. Go with the arrow up. And you will see it right here under 0. Summation and sigma. So press 0. And now the calculator is waiting for us to put in whatever we need to put in. I cannot put I or J. We prefer for the index I, J, or K. I can't. I have to use X. So from X equals 1 all the way up to 10. And now from what? These are the parentheses of the summation notation. I will also put my own parentheses around I squared. It may work without. I don't trust it. I don't even want to check. I prefer putting it with parentheses. I've had in the past situations in which it worked without my own parentheses. It didn't, so forget it. So we have from I equals 1 to 10, from x squared, because that's what I have, I squared, and just press enter. It will calculate. It'll give us 385. Okay. Now, let's look at more simpler examples, but there are 3 properties. Three properties of sigma. 1 and 2 I will present together. And there is a third one. The first one says that if I have the sum from, let's say, for example, I squared plus I cubed from I equals 1 through 10. This can be written as I equals 1 through 10 from I squared plus the sum from I cubed from I equals 1 through 10. No, we are not distributing the symbol. We are only saying that if I have a sum of 2 general terms, I can add the sum of the first general term plus the sum of the second general term. What will be the second one? Of course, with negative. So if we add terms and we have a summation notation outside, we can create as many terms as we want with the summation in front. If it's addition or subtraction, it doesn't make any difference. And the last one is the sum, let's say, of 5I squared from I equals 1 through 10. It's a constant. The constant goes in front. So this is 5, the sum of I squared from I equals 1 through 10. Let's practice this with simple examples from your book. And then we can move on to the last step of sequences. Okay. On page 7.
Can you go over the third step one more time? Sorry.
It's a constant multiplied by I squared. So this will be basically, so I have 5I squared from I equals 1 through 10. I will have 5 times 1 squared plus 5 times 2 squared plus 5 times 3 squared plus dot 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 plus 5 times 10 squared. And I can pull 5 in front. And I have 1 squared plus 2 squared plus 3 squared plus dot 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 plus 10 squared. Which means that this is, since it's multiplied, I can take the constant in front of the summation notation. And this is the same with 5 times the sum from I equals 1 through 10 from I squared.
Okay, thank you.
Is that better?
Yeah.
In other words, we can factor out 5. That's what it really means. Okay, so back to the book so we can practice this. On page 752. Let's look at 34. In 34, we have the sum from K. They're using K. The index, normally it's I or J or K. You can use any index. If you want to put A, put A. It doesn't matter. So as long as you have the same index in here and here. First of all, let's expand this and see what it means. Can anyone give us the first term? First of all, how many terms will the sum have? How many terms?
4.
Yes. When k is 1, when k is 2, when k is 3, when k is 4. Excellent. So can anyone give us, without calculation, the first term when k is 1?
K squared?
1 minus 3.
Oh,
Negative 2.
1
1.
minus 2. 1 plus 2.
Correct. We're done with k equals 1 plus. Now k equals 2.
Two minus three. 2 plus 2.
When k is 3. Can everyone follow? Yes? Is this clear? And we have to add because of the summation notation. Can I do this by hand? Yes, and then we'll do it with a calculator. 1 minus 3 is negative 2, and negative 2 times 3 is negative 6. Negative 1 times 4, negative 4. 0, goodbye. 4 minus 3, 1. 1 times 6. Negative 4. Let's see how we do this with a calculator. Ready? Okay. So math, go up to summation notation. We have from k equals 1. I have to put from x equals 1, and it goes up to 4. Again, I'm going to put my own parentheses. So I have x minus 3, close parenthesis, and x plus 2, close parenthesis. Press enter, and we have to get negative 4. Negative 4. Is this clear?
Yes.
Perfect. Let's look at another. Let's see, one with factorials. Wow. Let's see how that works.